In this presentation, we have to talk about Stark effect in the first excited state of hydrogen. You know that in the case of ground state of hydrogen, there is no first order Stark effect because of even parity. N equal to 1 state is a ground state. N equal to 2 state is a first excited state. Suppose the value of n is known to you. The possible values of orbital angular momentum quantum number L are justified by the formula 0 to n minus 1. Suppose the value of n is known to you or n is given to you, L can have 0 to n minus 1 values. Here n is equal to 2. Therefore, the possible values of L are 0 and 1. For the given value of L, the magnetic quantum number M can have minus L to plus L values. If L is equal to 0, the value of M is 0. Suppose the value of L is equal to 1. The possible values of M are minus 1, 0 and 1. For the given value of L, the magnetic quantum number can have 0 minus L to plus L values inclusive of 0. For L is equal to 1, the values of M are minus 1, 0 and plus 1. With the help of these three quantum numbers, N, L and M, we can construct our eigenfunction because the eigenstate is given by the formula psi n Lm. Here the principal quantum number n is equal to 2. So in all the cases we have had 2. Then the next orbital angular momentum quantum number. Suppose the value of orbital angular momentum quantum number L is equal to 0, automatically the value of M is equal to 0. The next probability is L equal to 1. N equal to 2, L equal to 1. Suppose the value of L is equal to 1, the possible values of M are minus 1, 0 and 1. So you take the first combination, psi n equal to 2, L equal to 1, M equal to 0. Here n equal to 2, L equal to 1, M equal to 1. Here psi of 2, 1, minus 1 stands for n equal to 2, L equal to 1, M is equal to minus 1. So in this way, we can get 4 possible eigenstates. We know that for the given value of n, the degeneracy is n square. If n is equal to 2, the value of n square is 4. All the 4 eigenstates are having the same energy level. Therefore, the system is said to be in the state of degeneracy. Here the eigenstates psi 2 0 0, psi 2 1 0, psi 2 1 1 and psi 2 1 minus 1 are having the same energy eigenvalue. Therefore, the system is said to be in the state of degeneracy. With the help of these eigenstates, we can construct a circular determinant. The determinant is H1 2 0 0 2 0 0 minus E1. Here the meaning of H1 2 0 0 2 0 0 is equal to psi star of 2 0 0 H1 psi 2 0 0 beta. This is the meaning. Here H1 is our perturbed Hamiltonian minus E F R cos theta. Here psi 2 0 0 stands for the wave function corresponding to the principal quantum number n equal to 2, orbital angular momentum quantum number L equal to 0 and magnetic quantum number M equal to 0. Then d tau volume element is r square sin theta d theta dr and d pi. This is the meaning of h1 to 0 0. Now we have to construct this. Here E1 is the first order energy correction. H1 to 0 0 to 1 0, H1 to 0 0 to 1 1, H1 to 0 0 to 1 minus 1. Entire should equal 0. Then next H1 to 1 0 to 0 0, H1 to 1 0 to 1 0 minus E1, H1 to 1 0 to 1 1, H1 to 1 0 to 1 minus 1. H1 to 1 1 to 0 0, H1 to 1 1 to 1 0, H1 to 1 1 to 1 1 minus E1, H1 to 1 1 to 1 minus 1. Last row, H1 to 1 minus 1 to 0 0, H1 to 1 1 is 2 1 minus 1, H1 to 1 minus 1 to 1 0, H1 to 1 minus 1 to 1 1, H1 to 1 minus 1 to 1 minus 1 minus E1. So this is a circular determinant. Just I have written this eigenstate in terms of column 2 0 0 2 1 0 2 1 1 2 1 minus 1, and in terms of row 2 0 0 2 1 0 2 1 1 2 1 minus 1. Simply we can construct the circular determinant. In the circular determinant, elements with even parity are vanished. First of all, we should understand about the parity. Already we talked more about parity in the case of ground state of hydrogen atom. So here, the elements with even parity are vanished. You know that parity is given by the formula minus 1 power L. L is the orbital angular momentum quantum number. Suppose L equal to 0. If L equal to 0, pi equal to minus 1 power 0, which is equal to plus 1. If the value is positive, then the parity is even. If L equal to 1, pi equal to minus 1 power 1 equal to minus 1. Here the parity is odd. If pi is positive, then the parity is even. If pi is negative, the parity is odd. See here the value of L is equal to 0. Here also 0. So the parity is even. So this term is vanished. This term value is 0. Here L equal to 0, L equal to 1. This term is present. L equal to 0, L equal to 1. This term is present. L equal to 0, L equal to 1, this term is present. L equal to 0, L equal to 1, this term is present. Here L equal to 1, L equal to 1. For L equal to 1, the parity is odd. Here also L equal to 1, the parity is odd. Odd into odd, even. So this term is vanished. L equal to 1, L equal to 1. Odd parity into odd parity. So even. So this term is vanished. On the same background, this term is vanished. 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 So that except the first column and first row, all the terms are vanished on the basis of even parity. Now we have to construct the new determinant. This is the new determinant, and the new determinant, except these two terms, all other terms are vanished. Only these two terms are retaining. All other terms, 1, 2, 3, 4, 5. These terms are vanished. 2, 3, 4 terms. 1, 2, 3, 4. These 4 terms are to be vanished. Now you have to prove this. For that, take this first term, H20, 211. H1 of 200, 211 is equal to psi star of 200 H1 psi 211 d tau. This is the value of H1 200 211. Now the value of psi 200 equal to 1 by 32 pi a0 cube inside the root 2 minus r by a0 e power minus r by 2a0. This is the value of psi 200, and psi 211 psi 211 equal to 1 divided by 32 pi a0 cube inside the root r by a0 into root 2 sin theta e power I pi into e power minus r divided by 2a0. This is value of sin 211. Now you have to substitute all the values in the above equation. That is H1 200 211 equal to triple integral 0 to infinity 0 to pi 0 to 2 pi 1 divided by 32 pi a0 cube 2 minus r by a0 e power minus r divided by 2a0. This is the value of psi star of 200. If you take the complex conjugate to psi 200, we can get the same value. Then H1 minus E F R cos theta. This is the value of H1. Now we have to substitute the value of psi 2 1 1 and beta. Psi 2 1 1 is 1 divided by 32 pi a 0 cube into r by a0 into root 2 sin theta e power I pi e power minus r divided by 2a0 into d tau volume element r square sin theta d theta dr into d pi. This is the value of h1 200 211. Now we have to separate this into r part, theta part and pi part. This is equal to integral, take out the constant terms, minus EF divided by 32 pi, see here, 32 pi a0 cube into 32 pi a0 cube. Take this a0 outside and root also. Pi a0 power 4 into root 2. Then align the r term 0 to infinity. 2 minus r by a0 e power minus r divided by a0. E power minus r by 2a0 into e power minus r by a0. 2a0 equal to e power minus r divided by a0. A power m into a power n is equal to a power m plus n. Then combine the r terms. R square into r square, r power 4. R power 4 into dr. Next align the theta terms 0 to pi. Cos theta, sin theta, sin theta. So sin square theta, cos theta. Sin square theta, cos theta, d theta. Next align the pi terms. E power I pi into d pi. Limit varying from 0 to 2 pi. So this is the value of h1 200 211. But we know that the value of e power I pi d pi, limit varying from 0 to 2 pi equal to 0. Therefore, the term h1 200 211 value equal to 0. This term is vanished. h1 200 211, this is vanished. If h1 200 211 is vanished, automatically h1 211 200, this term is also vanished. If this is 0, this is also 0. In the same manner, we have to prove the value of h1 200 21 minus 1 is also 0. We will prove the same. Now we have to prove the value of h1 200 21 minus 1 is also 0. Further write down h1 200, that is psi star 200 h1 psi 21 minus 1 into d tau. This is equal to triple integral of 1 divided by 32 pi a0 cube inside the root 2 minus r by a0 e power minus r divided by 2a0. This is the value of psi 200. Then h1 value minus ef r cos theta, then psi 2 1 minus 1 value 1 divided by 32 pi a0 cube inside the root r divided by a0 into root 2, the same sin theta but e power minus I pi, e power minus r divided by 2a0 into r square sin theta d theta dr into d pi. In the case of psi 2 1 plus 1, we have used e power I pi. In the case of psi 2 1 minus 1, just you have to change the sign of phi, e power minus I pi. Now you have to find out the values, 0 to infinity, 0 to pi, 0 to 2 pi. If you align the terms, we can get the pi term in terms of e power minus I pi into d pi. The pi term value is e power minus I pi into d pi, limit varying from 0 to 2 pi. The value of e power minus I pi d pi, limit varying from 0 to 2 pi is 0. Therefore, the entirely vanish. So the term h1 2 0 0 2 1 minus 1 is also 0. Then we may say this value is 0, so this is also 0. So except two elements, all the elements are vanished. This is 0. Say this is 0, this is 0. Then this is 0, this is also 0. Now we have to find out the value of h1 2 0 0 2 1 0. h1 2 0 0 2 1 0 is equal to psi star 2 0 0 h1 psi 2 1 0 beta. This is the value of h1 2 0 0 2 1 0. Now we have to substitute the values of 2 0 0 and 2 1 0. Now we will carry out the rest of the things. This is equal to triple integral of 1 divided by 32 pi a0 cube inside the root 2 minus r by a0 e power minus r divided by 2a0. This is the value of psi star 2 0 0. Then h1 value minus e f r cos theta. Then psi 2 1 0 value is 1 divided by 32 pi a0 cube inside the root r by a0 into cos theta e power minus r divided by 2a0 into volume element r square sin theta d theta dr d pi. Here the limit varying from 0 to infinity, 0 to pi, 0 to 2 pi. Now we have to solve the integrals one by one. For that we should simplify the above equation first. Take this 1 by 32 pi a0 power 4 outside. See, 1 divided by root of 32 pi a0 cube. Here also 1 by root of 32 pi a0 cube. So without root we can write 32 pi a0 cube. Here one a0 is present, so a0 power 4. Then write down this minus e into f. Minus e into f. Align the r terms 0 to infinity. 2 minus r by a0 e power minus r divided by a0, because e power minus r divided by 2a0 into e power minus r divided by 2a0 equal to e power minus r by a0. Then align the r terms, r square into r square, r power 4, r power 4 dr. Then align the theta terms 0 to pi, cos theta, cos theta, cos square theta into sin theta, that is sin theta cos square theta d theta. Then align the pi terms, limit varying from 0 to 2 pi into d pi. So the above integral is separated into 3 compartments, above equation. See, 32 pi a0 power 4, 2 minus r by a0 e power minus r by a0, r power 4 dr, r into r square, r power 4. Then sin theta, cos theta into cos theta, cos square theta d theta. Then integral d pi, limit varying from 0 to 2 pi. Now you have to simplify this further. Say h1 200 211 equal to up to 210 equal to minus e f divided by 32 pi a0 power 4, then 0 to infinity 2 minus r by a0 e power minus r by a0 r power 4 dr. The value of this integral sin theta cos square theta d theta is equal to 2 by 3. Integral sin theta cos square theta d theta, limit varying from 0 to pi, is 2 by 3. Then integral of d pi is pi. If you apply the limit, 2 pi is the answer. So this integral value is 2 by 3. This integral value is 2 pi. Just we have substituted the values. Now we have to solve this integral alone. We should find out the value of this integral. This integral value should be evaluated. For that we have to use our gamma of n formula. Take this integral 0 to infinity 2 minus r by a0 e power minus r by a0 r power 4 into dr equal to what? For that, put r by a0 equal to eta. then r equal to a0 into eta, dr equal to a0 into d eta. Here a0 is our Bohr's radius, which is a constant term. Now substitute all these values in this equation. This is equal to integral limit varying from 0 to infinity 2 minus eta, then e power minus eta, r value is a0 eta whole power 4 because r power 4, then dr is a0 into d eta. Now this is equal to, see here, integral limit varying from 0 to infinity 2 minus eta e power minus eta a0 power 4 eta power 4 a0 into d eta. Just I have multiplied 2 minus eta into e power minus eta a0 power 4 eta power 4 a0 into eta. Now a0 power 4 into a0 is a0 power 5. This is equal to a0 power 5 into rest of the quantities 2 minus eta e power minus eta, then eta power 4 d eta. Now you have to simplify this further. This can be separated into a0 power 5. See this, 2 into e power minus eta, eta power 4 d eta. 2 into integral e power minus eta, eta power 4 d eta. 2 into this much minus of integral, so here eta into e power minus eta, eta power 4 d eta. Eta power 1 and eta power 4 is equal to eta power 5. So into e power minus eta, eta power 5 d eta. The entire is multiplied by a0 power 5. We know that gamma of n equal to e power minus x power n minus 1 into dx. This is the formula for gamma of n, gamma function. Gamma of n is equal to e power minus x power n minus 1 into dx. See, this is in the same form, e power minus eta, eta power 4 into d eta. Therefore, n minus 1 equal to 4. In this case, n minus 1 equal to 4, therefore n is equal to 5. Here, n minus 1 equal to 5, n equal to 6 in this case. So this is equal to a0 power 5, 2 into gamma of 5. Here this 2 is present only for the first integral, minus gamma of 6. Now, this integral is equal to a0 power 5 into 2 into 4 factorial. Gamma of n equal to n minus 1 factorial. This is the formula. Gamma of n is equal to n minus 1 factorial. If it is the case, gamma of 5 equal to 5 minus 1, 4. 4 factorial. So this is a0 power 5, 2 into 4 factorial minus gamma of 6 is 5 factorial. 4 factorial is 24. 1 into 2 into 3. See here. 4 factorial. 2 into 3 6, 6 into 4 24. This is 5 factorial. This is equal to a0 power 5, 2 into 24 minus 5 factorial is 120. This is a0 power 5 into 48 minus 120. This is equal to minus 72 a0 power 5. This is the value of this integral, minus 72 a0 power 5. Now we have to substitute all the values. H1 200 210, which is equal to minus E F divided by 32 by a0 power 4 minus 72 a0 power 5 into 2 by 3 into 2 pi. Pi cancelled out. Then 2 into 2, 4 and 8, then 24 and 3, minus to minus plus. So the value is 3E F into a0. Here a0 power 4, a0 power 5. So the value of H1 200 210 equal to 3E F into a0. So instead of this term, we have to put 3E F into a0. Therefore, this value is also the same 3E F into a0. F into a0. By solving this determinant, we have to find out the value of E1. For that, consider this determinant. This is equal to 0. This is in 4 by 4. To solve this determinant, we have to reduce this in terms of 2 by 2. Therefore, this is minus E1 into, leave this column and the row, minus E1 0 0 0 minus E1 0, then 0 0 minus E1, then minus 3E F a0 into, leave this column and this row, 3E F a0 0 0, this row and this column, 0 minus E1 0 then 0, 0, minus E1. Then these are all the zeros. 0 into anything, 0. So that entire should equal 0. Now we have to solve the above. Now this is modified as minus E1. It's not E power 1 minus E1. Just here minus E1 into E1 square minus 0 minus 3EF A0 into 3EF A0 into E1 square minus 0. Entire is equal to 0. This is minus E1 into minus E1 plus E1 square into E1 square. Here minus 3 EF A0 whole square into E1 square is equal to 0. Now we have to simplify this further. E1 square is E1 square, take it out, E1 square minus 3E F A0 whole square is equal to 0. Just I have taken out this E1 square as a common term. So E1 square minus 3E F A0 whole square entire is equal to 0. From this relation, E1 square is equal to 0, or the term present inside the square bracket, E1 square minus 3EF A0 whole square should equal 0. Therefore, we can have 4 values. E1 equal to 0, comma 0, then plus 3E F A0, comma minus 3E F A0. If E1 square is equal to 0, E1 equal to plus 0, that is one root, another root is 0. E1 square minus 3EF A0 whole square is equal to 0. E1 square is equal to 3EF A0 whole square. Therefore, E1 equal to plus 3EF A0 and minus 3EF A0. So, these are all the 4 possible values. Now, we have to provide the interpretation for these 4 possible values. For the 4 roots, we have to provide our explanation. The behavior of hydrogen atom in the first excited state, that is n equal to 2 state, is like a permanent electric dipole moment of magnitude 3A0, which can be oriented in 3 different ways. One state parallel to the field, that is positive value, 3EFA0. One state anti-parallel to the field, minus 3EFA0. 2 states perpendicular to the field, 0 and 0 are taken for our consideration. The 2 states are perpendicular to the field because we are applying the field along the z direction, z equal to r cos theta. If theta is 90 degree, cos 90, 0. Therefore, these 2 are perpendicular to the field applied. Is z equal to r cos theta. If theta is 90 degree, then cos 90, 0. So these two values specify the two states perpendicular to the field. That's all about the Stark effect in the first excited state of hydrogen atom. Thank you.